Hello everyone. The main objective of this particular video is to educate you on what makes the SAM hammers from NVTech so unique and special. If you are doing any kind of modal analysis work, you either already own one of these systems because it's an absolute a game changer, or if you don't own one, you should seriously consider getting one. Not regardless of what kind of sensor you're using on the back end, whether it's vibrometers or something else. An automated modal hammer makes things go so much smoothly, and it has so many benefits over the traditional handheld impact hammer. Of course, we are talking about impact testing. Shaker, a completely different animal. So let's just go through the two models that NVTech and the inventor of these modal hammers, Professor Peter Bleschke, has come up with to cover a broad spectrum of applications. So you got the SAM1 on the left here, and then SAM3 on the right. The SAM1 is the smaller one, goes to higher frequencies. Not too high of force levels, but that's on design. It doesn't require so much at higher frequencies. These are more for lightweight, fragile structures. For bigger structures, you got the SAM3, goes to much higher maximum forces. We're going to look at the minimum force as well, one of the specs that's kind of overlooked at times, and goes to up to 20 kilohertz. So these are the two sort of models that you're looking at, some basic specs here for your sort of review, and see which one fits better. Now let's just go through a few things that make these automated modal hammers, and especially the SAM1s and SAM3s, so unique. Of course, no double hits. I still have nightmares about double hits during my grad school using the manual handheld hammer. And the repeatability. These are the two sort of prerequisites that makes an excitation unique and special. And that's what you see here on the left, on the right side. Handheld hammer, the excitation force levels, you just cannot avoid, it's just hard to do extremely repeatable force inputs, which is not the case. You can do extremely repeatable and no double hits with automated modal hammer, whether it's a SAM1 or a SAM3. Just to make the point here, because the excitation is so repeatable, there are researchers who actually study nonlinearities using these SAM hammers. And what you're seeing here is, as you reduce the force input on, when you're exciting a structure, you would expect your, the frequency to stay the same and just kind of the amplitude to reduce if it's a linear structure. So because the excitation is so repeatable, you can see that you can also study the nonlinear behavior, because here what you're seeing is with the reduction in force input, you are not only seeing a change in amplitude, but which is expected, but also something not expected is change in the natural frequency. So this is what this extremely repeatable behavior enables you. The other beauty is, if you are already a user of our scanning LDVs, the guidelines are laid out beautifully to seamlessly integrate this modal hammer, all the settings that you need to make it work just right, with the scanning LDV. So you're using a scanning LDV for data acquisition, and then the modal hammer, and there's very good documentation on how to set it up with the scanning PSV software. Also, here's another one that kind of stands out when it comes to what makes this SAM hammer so unique. All these granular controls. When you look at the software, it's beautifully done. You have control over the velocity, of excitation, the stop angles, the number of hits, all these finer settings. You can load settings and recall settings, all that stuff. You can control how many hits. So it's just giving you a lot more sort of control to get your excitation just right, depending on what you're exciting. So that's another one. And one of the last things that before we look at some example setups is Professor Bleschke's group also did an endurance test, 1 million hits. And then the they had this sample surface, of course. But what's very unique here is that after 1 million hits, I mean, the force sensor, it's like, yeah, there's some scuff marks, but it's almost like undamaged. Something that's just, incredible after 1 million hits. On the left in the table, what you're seeing is the natural frequency of the arm. The arm is one of the most critical components of these modal hammers. So the natural frequency of this arm was measured using a laser Doppler vibrometer, of course, and then the natural frequency was measured multiple times before the 1 million hits and after the 1 million hits. And so what you're seeing is the change in damping and change in the natural frequency of this arm. And you can see that the change is just very, very reasonable changes after 1 million hits. So, I mean, we don't have that many customers who go to 1 million hits, but the point being that the endurance and the robustness of these modal hammers is just unparalleled. So that's what we look at for when we are looking for an excitation mechanism. Minimum force, this is a spec that's not that prevalent to be given. So this test was done to show that you can go to very, very, very low levels of forces as well, which is critical for some of these really fragile small structures. With the SAM1, which is the smaller hammer, lower force, lower max force, and higher max frequency, you can go to less than a Newton of force input, which is just unbelievable. And with the SAM3, 5 newtons, so that gives you a range of 0.8 to 200 newtons with the SAM1, and 5 to 2200 newtons with the SAM3, which is quite a spread. So that gives you, the basic spec and what really makes these systems so unique. Some of the setups, you can see here, this is in a very lightweight structure where, really you want minimal effect from your excitation. Here's another one. This was recently done with one of our applications engineers in the Plymouth or Michigan testing lab, where we were using the SAM1 for a model airplane to excite it and do some modal analysis work with our 3D RoboWeb system. SAM3 example here, brake rotor testing is a classic one where you really want that excitation to be extremely repeatable. So this has been, one of the first sort of applications that these modal hammers were used for, more than a decade ago. A video here just to kind of show you one of the SAM hammers in action. Here, what you're seeing is the SAM1 is mounted using a magnetic base and a hydraulic arm, and 3D scanning vibrometer is being used for doing the data, basically the vibration sensing. And with each hit, the trigger is happening, the measurement is being triggered, and the data is being recorded in the PSV software of in Polytech. So I hope this gives you an idea. What is SAM? What are the different models? What makes SAM so unique, whether it's repeatability, no double hits, this granular control, or just endurance, 1 million hits with barely any damage. So if you are into modal analysis, you absolutely should consider this as an essential component in your toolkit. If you have any questions, reach out to us. We are here to help. Thank you so much for your time. Until next time, bye-bye.